Okay, the sine rule. The sine rule is also used to find unknown sides and angles in non-right-angled triangles. Now, cosine rule is actually we use when we cannot use sine rule. So first, your trial will be the sine rule, because its sine rule is easier to use. So you just use the sine rule wherever you can, and then if it doesn't work, obviously use cosine rule. Now this is the cosine rule. You need to memorize this, and the proof will be, so in triangle ABC, there's a triangle ABC, draw a perpendicular AD with a length P and let CD equals X. So if I call that X, and that was supposed to be A, so to get the BD, obviously A take away X will be the rest. Okay, so that's the introduction of that. And then, I'll just copy that again. And now, to prove this, our goal is to get this. Whatever we're using here, we need to get this. So I can see I need to get B square, C square, and cos C, something like that. So, I'm going to show you the whole thing. And in triangle ACD here, I want to get B square. So I'm going to use the Pythagoras. B square equals X square plus P square. That's my number one. And I need a cos C. So I'm going to bring up cosine C equals, what is it? So car. A over H will be X over B. And then I'm going to make the X the subject so that I will have nice B cos C. I can see B cos C right there. And that was just for this triangle. Now moving on to the triangle DAB. Now I need a C square. So C square equals what? B square plus A minus X square, because C is the hypotenuse, opposite the right angle. And if I sort of put it all together, and you can see something familiar here, X squared plus P squared, which is same as that, X squared plus P squared. So I can move this one, replace this 2 into B squared. If I did that, it looks almost like this, isn't it? But except the this one's got X. Now, there you go. X we can replace with a B cos C. And if I do that, here we go. We have the answer for that. Excellent. Now, this is to find the unknown side. And what if I want to find unknown angle? Now, only angle part here is cos C. So I'm going to make the cos C the subject. So what I've done is I'm just swap this around so that I'll make the cos C is positive. So I've done that. I don't need 2AB on the left hand side with the cos C. I want it to be by itself, so I divide it by 2AB, and then I will get that. I'll just change into theta, because then it'll be like C equals, it doesn't look like angle. So I change into theta. Because I move the cos the other side, it'll be inverse cos, and the whole thing here. So, in a nutshell here, just the quick formula to remember. From here, if I want to find the unknown side, I don't need a C square. I need a C equals. Now, with a square, it'll be C square equals plus minus square root. But we do not include a negative, because C is a length. We don't use a negative length, so only the positive is included. Okay, so this is just a quick version of the formula. Now you're ready to do example 1. Find the value of X correct to the nearest whole number. Okay, now you need to check whether we can use sine rule. I know we've been learning cosine rule, so you know it's going to be cosine rule, but in the exam they're not going to tell you which rule to use. So you need to learn to examine before you jump into the working out part. So I'm going to, remember with the sine rule, you have to match up with the angle and the side. So that's not a problem, we can match up. Now this is a problem. There's no angles to the two sides that I can match up. Therefore, I cannot use, no thank you, I can't use that. So we have to use cosine rule. Now remember the formula. I'm just going to use a quick one. So this is the unknown side. So now the A and B is one that is surrounded, protecting the angle you have to use. So it'll be 5.6 squared plus 6.4 squared minus 2 times 5.6 and 6.4, and then cos the angle is in between two sides, 112. I mean, it'd be only one angle anyway, so it's only one you can use. So if you do that, now what's the question say? To the nearest whole number. So don't leave the answer to like 9.9894. Make sure you answer the question. It's a 10. And it's there's no centimeters or meters, so probably put units as a length. Example 2. Part A. Find the theta in degrees and minutes. Okay. Again, we need to think about, can I use sine rule or not? So if I match up here, and then I can't match up, same as a previous question, so I can't use it, I have to use cosine rule. So if you didn't memorize the formula of the angle, I'm just going to use the side one and then make the theta the subject. So we're going from, remember that c squared equals a squared plus b squared minus 2ab cos c. So this is my angle and it's surrounded by length is a 6 and 5. So that's opposite. So always the c squared is opposite to the angle that you have to use. So it'll be 3 squared equals 6 squared plus 5 squared minus 2 times 5 times 6 and then cos c. Now I've done that and I'm going to swap this so that I can have a positive. So I'm going to have 60 cos theta equals 36 plus 26 minus 9. And then I'm going to divide it by 60 because I want to be cos theta will be the subject. And I've done that and simplify it. And of course, these goes to the other side, it becomes inverse cos. And then you use, obviously, DMS to get to the degrees and minutes. Part B. Okay. Evaluate angle BCA. BCA. So this is the angle that we're looking for. And by now you can tell you can't use sine rule. It's cosine rule. And I'm going to use the quick formula one. So whatever it is, surrounded, and it's a square, and the one that's opposite to the angle is the one that you have to take away. And on the bottom, 2AB is the one that is 2 times of the one that is surrounded around the angle. Okay, now interesting part here, this one, if you just calculate it separately, you will get negative value. Why? Because it's going to be obtuse angle. Obtuse angle is the second quadrant, which is negative for cosine. Okay, so just interesting part there. You have to remember all station to city. Example 3, a regular hexagon. Hexagon is a 6, isn't it? A, B, C, D, E, F. If you didn't know, just count the letters. 1, 2, 3, 4, 5, 6. So it's a 6. Has sides 5.5. It's a regular, so all the sides are equal. And the length, find the length of AD. And then part B says find the angle ADF. Okay, so I sketched the hexagon. And now you're probably wondering how do I find total angle of a regular polygon? It's counted by how many triangles. One triangle is just 1, so 180. Okay, that's not a problem. Times by 1 equals 180. Now, with a rectangle, quadrilateral, you get 2. 2 triangles, yeah, times by 2, so 360. Yes, and then with pentagon, what would you get for pentagon? Let me see. So 1, 2, 3. So I'm going to go 3. So when you times 3, 540 degrees. That's a total. Now with the hexagon, so 1, 2, 3, 4. I'll get 720. Now there's 6 of them, so you divide it by 6, you will get 120. So each individual angle of regular hexagon is 120 degrees. All right, so if I summarize that and sketch it again, it'll look a little bit like this. So to find the AD, length of AD is what? AG. Well, I just named the G and H. So if I add the side AG, GH, HD, we'll get AD. Now just remember, this is same as that because everything will be the same length. Now this part is same as this, 5.5. Okay, so all we have to find is really AG. So I'm looking at triangle ABG. So here, this one. I'm looking at that. So that's my angle. And I'm looking for AG. So that's my question mark there. So that's my adjacent. And that's my hypotenuse. A and H is car, which is cos. Cos 60 is AG over 5.5, and you'll get 2.75. And obviously, I know GH is 5.5, HD is same as AG, and my length for AD is 11 centimeters. Not bad. And the next one, I'm just going to have to tell you this video is going to be a little bit long too, so have a break if you need to. And the angle ADF, let's see, ADF. So this is the angle we have to look for. There's a couple of ways of doing this. You can use this triangle, okay, and to find the cosine rule to do that. Or you can use this right angle to find it. Now, using this, it's going to be a little bit painful, so I wouldn't really recommend, but if you want to, please feel free to do it. Okay, so I'm going to use this triangle to find this angle. So I know this length is what? 8.25 because I added this together, and I need to find the FG. Okay, so if I find the FG and I've got the this, I can use tan to find angle. Okay, so I'm looking at here, so that will be my 60, and I'm looking at this triangle. That's 2.75, that's 7.5, and that's 10. That's a question mark I'm looking for. So tan 60 is FG over 2.75. So the length is 4.763. And then from triangle FGD, I'm going to use tan theta equals FG over DG, which is DG is 8.25, and inverse tan, I will get that much, but to the nearest degree, I get 30 degrees. All right, now that was the sine rule. Now I'm going to just do a little bit of area of triangles. Now you can relax a little bit because it's not too bad. Area of triangle is one of those, the easiest one. Okay, sine formula for the area of a triangle. So that's what it's given. But what's that? Area of a triangle is what? Half times base times height. So I'm going to actually prove this. So from triangle BCD here, from here to here, I just conduct the perpendicular line going through the B and then meeting at the D of the CA. Now half times base is b. Now we need to find the height, isn't it? If I can replace height with some sort of a trig ratio, I think I can get this. So we need to find the sine c. So I'm going to use sine c here equals b over a. The reason I sketched the perpendicular to find the height. Height has to be perpendicular with the base. So if I do that, the height is what? A sine c. And if I replace that with the height, I will get this. Okay, so that's not too bad. Let's have a look at the example. Find the area of triangle ABC corrected 2 decimal place. So that's my angle. Area is half times A times B times sine C. Now with this A and B business, it's just where it's right next to the angle that we're going to use. Not this one. This is actually just to distract you. All your information should be linked together, all three of them. So half times 4.3 times 5.8 times sine 112 degrees and 34 degrees, and you will get that. Now, because it didn't give us measurements, you might just use units squared because it's area, or u squared. Okay, example 2. For this figure, find A, B, C there. First one says AC. Oops, couldn't see that. Okay, so AC is the one we're looking for. I'm just going to highlight this for just easier. Okay, that's what we're looking for. Now, you need to think about this. How are we going to do this one? Because I can match up. That's all right. But I don't have this, isn't it? But I can find this angle, right? Because it's got two other ones. Using angle sum of triangle, I can find this one. Therefore, I can find this angle, and I can use what? Sine rule to find it. So let's do that. I found the angle ACB using angle sum of triangle, and then I'll use a straight angle to find this angle, which is 102. And using the sine rule, all that, I can find AC. That's not too bad. Okay, that's my dog again. And B, and then we have to find the area of ACD. Okay, so ACD, that's the area we have to find. That's not too bad because we already found AD, which is 5.6. I've got this, and the angle was 102. So I've got all this three information I need. I can find the area. So it will be half times AC times CD times sine C, which I have all the information up there. Half times 5.6 times 6.7 sine 102 degrees. I will get 18.35 centimeters squared. Excellent. And then part C says find area of ABC. So I just re-sketched this one. Okay, so I have a few options here. Let's think about this. I can use, if I can find the BC, I can use 5.6, 78 degrees, and BC. Or I can use 5.6, 58 degrees, and if I can find AB by using sine rule, I can use that as well. So I've got these two options, but I'm going to use the first one. So I have to find the BC first. BC using the sine rule. So I've just matched up. The unknown side comes on the top. So BC over sine 58 matching. And then 5.6 matching with the sine 44. I'm going to make the BC the subject by timesing by sine 58 on both sides. I'll get 6.8. And then the area, so I'm going to put 6.8. So these. I've got all three that I need. Half times AC times BC times sine 78, which AC was 5.6, and the BC is 6.8, and sine 78, I will get 18.6 centimeters squared. And that's not all. We have a bonus question. Aren't you lucky? Okay, let's have a look. Find the exact area. This is exact. That means just square root form. Okay, let's always remember. Of an equilateral triangle with a side 5 centimeters. So I already sketched this. And that means 5, 5, 5, all three sides are 5 centimeters. And each angle is 60. Why? Because 180 divided by 3, because they all have to have an equal angle. Therefore, area is half times 5 times 5. So I'm doing this. So all three that I need. And then sine 60. Now sine 60 is root 3 over 2. If you don't remember, go back to my other video and have a look at it and memorize them. And that's what it is. You can't cancel anything. Leave it as it is because the question said exact area. So answer is 25 root 3 all over 4 centimeters squared. Well done.